Okay, good morning, afternoon, or evening, depending on when you're watching pre-cal. 20 people, this is our sixth day today in geometric series. Okay, so our sixth day in the geometric series, 1.4. And today we have 4 jobs that I want to look at. Okay, I want to define the geometric series. I want to develop the formula for geometric series, which there are 2 different versions of it, depending on what you're given, that you can use. We're not going to really derive it. We're just going to state it and use it. Then I'm going to look at 3 examples, I believe. 1, 2, 3. Looks like 4 examples, actually. Sorry, guys. Looks like I'm going to do 4 examples in here. And then there's some 8 to 10 practice questions from the textbook. Okay, so let's start by defining here. What is this geometric series? So when I say geometric series, I'm basically saying that it's a sequence. And remember that a geometric sequence is when you have a term and you multiply it by a common ratio and you keep going up, up, and up, where the terms are added together. Okay, so looking at my first example, if I start with 14 and my common difference is multiplying by a half. So 14 times 1/2 is 7. 7 times 1/2, which is 7 over 1 times 1 over 2, will give you 7 over 2. 7 over 2 times 1/2 would be 7 over 4. 7 over 4 times 1/2 would be 7 over 8, and so forth and so on. That is the first geometric series because we're adding them in between instead of the commas. Here's another one where I'm just multiplying by 4. So 2 times 4 is 8. 8 times 4 is 32. 32 times 4 and blah, blah, blah as you go on. Of course, you could have a terminating series or one that's multiplied by a negative number so that it could alternate back like this one. So if I started with 1 and I was multiplying by negative 2, 1 times negative 2 is negative 2. Negative 2 times negative 2 is 4. 4 times negative 2 is 8. Negative 8 times negative 2 is 16. And of course, you can have a geometric series like this that terminates and stops there. So there's 3 examples of a geometric series. So the next thing that we're going to do is we're going to derive 2 formulas that we use. So let's start off with the terminologies. That we're going to use the same variables that we used in arithmetic, series, and sequence. And we're going to use Sn to represent the sum of the series. We also are going to use n for the number of terms, just like we always do. We're going to use T1 for that first term. Okay, and we're going to use, come on in if you have a question. I can just pause here. Give me a second. I'm going to pause, guys, and I'll be right back. I'm going to try to pause. Oh. Well, where's my pause button? There it is. Okay, it's hidden. Okay, I'll be right back with you guys. Okay, sorry about that, guys. So let's continue on here. Okay, sum of the series, Sn, n, number of terms, T1, first term, and R, common ratio. And remember, to get the common ratio, you divide the term ahead of the term behind it by the term behind it. So 4 divided by negative 2, 32 divided by 8, 7 over 2 divided by 7. That gives you the common ratio. Okay, so that gets us into what are the 2 formulas that we're going to use when we do this type of calculation with geometric sequences. So we have sums. We have 2 sum formulas. The first one is when you have T1, R, and N. So if you have those, it's T1 times R to the power of N minus 1 all over R minus 1. So this is when given T1, N, and R are known. Okay, so there's one if you know the final term, like something like this. So you can also do a second formula for sum. R times Tn, which I forgot to put the Tn up here, but I will in a minute. Okay, this is when T1, Tn, and R are known. So you don't know N. I guess we should put what Tn is, the nth term. Okay, so there's our two formulas that we're going to work with. So we're going to do some examples with this. We have about 4 examples that I want to do with you. So the first one I'm going to do is just, the first couple I'm going to do is just applying these two formulas. So if I had a sequence, or a series, pardon me, that, so find the Sn. Okay, so let's say I had 12, -6, +3, negative dot, all the way up to the 15th term. Okay, so I don't know what the final term is. I know what T1 is. I know what the number of terms is, 15, and I know the ratio if I do my dividing. So we're going to use the top formula. So that's this one. Okay, so here we have to figure out what R is because we don't know specifically. We have to calculate it. So R is going to be, say, T2 divided by T1. So -6 divided by 12. That's a half, negative a half. Okay, that makes sense. 12 times negative a half is -6. -6 times a half is +3. Okay, so now that we know that, we're going to plug it in and calculate it. Okay, I'm going to do it with fractions for this example, but you could use decimals. Just make sure when you're using decimals that you don't round off. Okay, so if we're doing fractions, we've got Sn equals 12 times R, which is -1/2, to the power of 15 minus 1. And R is -1/2 minus 1. Okay, so let's do our calculations here. Okay, 12 we'll leave out front. We'll go 15 to the -1/2 to the 15. So that's -1 to the power of 15, which is 1. And 2 to the power of 15, which is 32,768 if you do it on your calculator. Okay, and that's negative minus 1. So when we're minusing 1, if we turn it into a fraction, is just 32,768 over itself, right? Because that number divided by itself is equal to 1. So if we write 1 like that, we can do the math fraction-wise. And -1/2 minus 1, now again, minus 1 would be 2 over 2. So -1/2 minus 2 over 2 is -3 over 2. Okay, so we got some math to do here. So we're going to do the inside of the brackets first. 12 times -32769, because we're just adding that -1 to it, over 32768. Okay, and then we're dividing by 3 over 2. So when you divide by a fraction, you take the reciprocal and multiply. So we're going to multiply by the reciprocal, -2 over 3. So there's our math that we have to do. So there's going to be some reducing and some other things that happen in here. Okay, so if I were to do this,
values textbooks at the front entrance.
Okay, and I crunch these numbers together. 7, 8, 6, 4, 5, 6. That's positive because this is negative, negative, positive. 12 times this times 2. And then this times 3, which is 98, 304. And if we reduce that fraction, it's going to be 32,769 over 4,096, which is a good enough answer. Or if you did decimals, it ends up being 8.0002 something, 24 something, something, something. Okay, so do the fractions, or if you want to do decimals, you could do decimals. You could just don't round it off when you're multiplying. So there's an example of just determining a sum with that first formula. Okay, let's flip ahead. And we'll do well, let me leave it there in case you want to look at that for a little longer. Well, I develop a second example. Okay, the second example we're going to use is another one that we're going to use where you were given T1, Tn, T1, and R. So this would be the type 2 example. Okay, so example 2. Okay, so what I want to do here is, let's say we have a series that is 10, or let's say given Tn, T1, and R, so that you don't know what the number of terms is. So let's say we go 10 plus 5 plus 5 over 2. And we keep on going down, down, and down until we get 5 over 64. Okay, I'm going to use fractions again. Again, you could use decimals if you want, but just make sure if you do that, don't round anything on your calculator. Just keep it to the full decimals when you're doing that so that it doesn't give you the wrong answer. I like to use fractions because they give exact answers. And in grade 11 and 12, a lot of times you want exact answers. But it's not wrong to use decimals. So T1 is equal to 10. R, if we want to figure out R, we got to go 5 over 10, which equals 1/2, right? Multiply by half, multiply by half. Okay, and Tn is 5 over 64. We do not know n, so we have to use the second formula in this case. So if we remember what the second formula was, Sn is equal to T, what was it here? R times Tn, subtract T1, divided by 1 minus R. Or sorry, R minus 1, pardon me. Okay, so that's what we're dealing with there. So let's plug our numbers. Okay, R we've got as 1/2. Tn we've got as 5 over 64. Subtracting 10 all over 1/2 subtract 1. Okay, don't freak out because it's fractions. You can do this. 5 over 128 minus 10. Now, think of 10 as 128. So we've got to multiply 10 by 128. So this would be 1,280 over 128. That's 10. If we take this number and divide by 10. So all you're doing is take the bottom part, multiply by 10, put it over on top. That represents a 10. 1/2 minus 1 is negative 1/2. Okay, so now our equation is 5 over 128 minus 1280 over 128 divided by negative 1/2. So let's do that. Okay, 5 subtract this. So it's going to be negative 1275 over 128. And now we're dividing by negative 1/2, so that's like multiplying by negative 2. over 1. Okay, we can do a reduction here to 64 and negative 1, and then we can do our math. This would be positive 1275 over 64, which does not reduce. If you want to write it as a mixed fraction, that would be 19 and 59/64. Or if you like decimals, you can go 19.82 something. So those are our plausible answers. You could leave it like this, and that would be fine as long as it's reduced. So there's 2 examples, one using SN with a given R and TN and T1, and one with a given R, N, and T1. Okay, that's our second example. We're sitting around the 16-minute mark, so that's good. This should be about a half-hour video because we got a couple more we want to look at. Okay, what about if I give you, here, I'll give you one to try that's like this. Just try this one. So I'm going to say try this one, pause the video, try it, and then we'll do it together. So let's say, try this. And you have to decide whether you're going to use the first formula or the second formula. Let's say that we have 1, negative 3, positive 9, dot, 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 all the way up to negative 243. Find SN. Okay, pause the video for a few seconds and work it out. And I will work it out here with you when you unpause it. Okay, if you've unpaused, first thing we're going to do is T1 is 1. R is equal to negative 3 over 1, which ends up being negative 3, right? Okay, multiply by negative 3, multiply by negative 3. And Tn is equal to 243. Okay, so this is going to get us into using that formula for Sn, where we have given a Tn, R, and T1. Okay, same one we used here. Except I wrote the R in front, but it doesn't matter if the R comes there or second. Okay, so let's plug it in. Tn, negative 243, times R, which is negative 3. Subtract T1, which is negative, subtract 1. And then we have negative 3 minus 1. So this one's a little easier because there's no fraction involved. So if we take 243 negative times 3, or negative 3, pardon me, we get 729. Subtract 1 over negative 4. So this is going to equal 728 over negative 4, which we can reduce. So that's going to be negative 182 if we do the dividing. So that one, no fractions to worry about, a little easier. And hopefully you were successful in that. Okay, so that was try one. Let's do an example. My final example today is finding something within the formula, like n value or a T1 value or something like that. So let's do an example like that. And this will be our final example for today. And then I'll give you some practice. Okay, let's say that we have, find end. Okay, let's say that our series is 3 plus 6 plus 12, and then we keep on going all the way until we get to 3072. And we want to find n. Well, this is a two-stepper. Actually, let's do two findings. Let's make it a little more because we got lots of time here. Only 20 minutes. And SN. Put capital there. Sorry, let's do both. Why not? Okay, so finding N and finding SN. So let's do SN first of all, because that's easy. SN is we have T1, we have TN, and we have R as being, if we go T2 divided by T1, that's 6 over 3, which is 2. So let's go ahead and do that. So our formula is RTN minus T1 over R minus 1. So this is going to be 2 times 3072, subtract 3 all over 2 minus 1. Okay, 2 times that number is subtract 3 is 6,141 over 1, which is equal to 6,141. That's our total. Now to find N, we have to use the old formula. Tn equals T1. Okay, because if we go to the other, we could use the sum formula. We could use this one. Or we could use the original first one, which, oops, I forgot. Let me take a quick look here. Where is that one? There it is. Okay, so the one that has no, that's not it. Sorry, guys. There we go. The one that has the T1R. Okay, so we could plug in the numbers and try to figure out this one, but I'm thinking this one's probably, we could plug that number in, plug that number in, right? And figure out what R is, okay? So either one we can use. We can use this one or this one. Let's use this one just because it's got the sum formula in it. Hopefully we calculated the right formula. So 641 equals 3, and then R is 2 to the power of N minus 1 all over 2 minus over 1. Okay, so that makes it a little nice and easy for us. We go 6141, pardon me, equals 3 times 2 to the power of N minus 1. So in order to figure this one out, we're going to have to expand this 3 times this times 3 times that, or we could just divide it by 3 and then calculate it out. So let's divide it by 3. If it does go evenly, it would be nice. Let's check it out. 6141 divided by 3. It does go evenly, so that helps a little bit. So 2047 equals 2 to the power of N minus 1. So we're going to add 1 to both sides. 2048 equals 2 to the power of N. Now we figure out how many powers of N do we need. So guess and check probably works here. 2 to the power of what? Let's try 8. Nope, not enough. 2 to the power of 11. Perfect. Okay, so 2 to the power of 11 equals 2048. Therefore, N equals 11. Okay, so that gives us 3 or 4 examples of working with those formulas in sum. So that gets us to about 25, 26 minutes. Okay, that should be enough. I've only got, let's see, we've got a few practice questions here. Okay, so let's do our practice. Let's slide this down a little bit. So for the rest of the day, you can work on page 53. This is section 1.4, and you can do number 2, A and C's, number 3, number 4, and number 5. Let me just double check to make sure that I'm just looking up my old notes here. Yeah, and there's 4 in each one. So if you're getting it and it's working out good for you, and we're not really doing any word problems, we'll look at that maybe next day. We'll do the word problem section next day. So that should be enough. 27 minutes, not a bad length. So that should give you enough time to go through those ones. If you do have any questions, don't be afraid to ask. Okay, see you tomorrow. We'll do the second part.